It's time now to answer some questions about implicit differentiation. Exam questions, I mean. The first one is this one. It's a paper 2 from June 2006, and this is the question 5. The equation of a curve is 3x squared plus 2xy plus y squared equals 6. You can see here that this equation is implicitly defined. It is given that there are 2 points on the curve where the tangent is parallel to the x-axis. What does this mean? If it is parallel to the x-axis, means that the gradient is 0 on these points. Show by differentiation that at these points y equals minus 3x, and then you have to find the coordinates of the 2 points. So this is basically what it's asking, and this is the function. So first you have to differentiate it. Okay, you have different terms, differentiate each one individually. This one is going to be 0. So this one is easy to differentiate, that is just 6x. This one you have to use the chain rule, that's what I did over here. And this one you will have to use the chain rule as well, okay? So the outcome of this is just 2x dy by dx plus 2 times y, dx by dx is just 1. This is just 2y dy by dx. So you have here the 2 terms with dy by dx, put them together, send everything else to the other side of the equal, factorize the dy by dx, and finally send this to the other side as well, and here you have the expression for dy by dx. Equal it to 0. Okay, you want a point where the tangent is parallel to the x-axis, so that's basically when the gradient is 0. And obviously this only happens when the numerator is 0, which means that y equals minus 3x as you wanted to prove. So we're done for the first sub-question. Then the other one is to find the coordinates of the stationary points, right? Find the coordinates of the 2 points. All right, so now that we know that y equals minus 3x, you can go to the original function that is implicitly defined, substitute y by minus 3x, and eventually you have this quadratic. All you have to do is to solve it, and eventually you have 2 values of x. X equals minus 1 and x equals 1. When x equals minus 1, the y equals 3. When x equals 1, the y equals minus 3. So the coordinates of the 2 points are minus 1, 3, and 1, minus 3. All right? Let me see how many points you had for this question. 8 points. Okay? Next question. This is Spring 2011, question paper 31. The curve with the equation 6e to the power of 2x plus k e to the power of y plus e to the power of 2y equals c, where k and c are constants, passes through the point P with coordinates natural logarithm of 3, natural logarithm of 2. Show that 58 plus 2k equals c, 2 points for that. And the second sub-question, given also that the gradient of the curve at P is minus 6, find the values of k and c. So in order for you to solve this, you have to just plug in the values of p into the equation. All right, this is defined in terms of k. You know a point that belongs to the line defined by this equation, so just go ahead and substitute the point there. So on point P, the equation is just going to be this. I just substituted x by natural logarithm of y, of 3, sorry, and y by natural logarithm of 2. Okay? I use the rules of logarithms just to be able to solve this. 2 natural logarithm of 3 is the same thing as natural logarithm of 3 squared. Same thing over here. And 3 squared is obviously 9. 2 squared is obviously 4. And then you have e to the power of a natural logarithm of something, and that the result of that is just that something, okay? Which I put over here, and over here. And now it's a very simple question. 6 times 9 is a 54. That is 4. That is just 2k. That is c. And this is the equation that you wanted. Then the next one, you wanted to, given also that the gradient of the curve at P is minus 6, find the values of k and c. So you already know the gradient at this point. You already know the expression You don't yet. You need still to differentiate the original equation, which is defined implicitly, all right? So you just differentiate the whole thing by x, and then look at each term individually, and that's what I did over here. So this is just going to be easy to differentiate. That is just 2e to the power of 2x. This one, you will need to do the chain rule. So d e to the power of y by di times dy dx. Here you have you already have a term with dy by dx. And same thing over here. You will have to apply the chain rule here as well. And this will yield another term with dy by dx. So this is just e to the power of y. This is just 2e to the power of 2i. Now combine the terms with the dy by the x's. All right. Here you have it. Send everything else to the other side of the equal. Once you factorize the terms with dy by the x, send the coefficient of this also to the other side. And this is what you get. You know that at this point, the gradient is -6. So equal it to -6. And eventually you get this over here. Now, on point P, you must substitute the x and the y by the coordinates. That's what I did. And simplify it. And eventually, with this, I can get the value of k, which is 5. Once I know this, I go to the result of the previous alinea, substitute k by 5, and I get the value of c, which is 68. Last question, last exam question is this one. This is paper 3 from when? May, June 2008. The question says, the equation of a curve is xy, open brackets, x plus y, close brackets, equals 2a cubed, where a is a non-zero constant. It's going to be important at the end. Show that there is only one point on the curve at which the tangent is parallel to the x-axis. Again, what does this mean? It means gradient 0. And find the coordinates of this point. Total of 8 points for this question. All right, over here, I just expanded the brackets. It will be simpler to differentiate. All right. And then differentiate as usual. Don't forget that a is a constant, so if you differentiate this side, this is going to be 0. Again, you have to apply the product rule over... you don't have, sorry. You just have to apply... Okay, so differentiate this, and this is going to be x squared dy by dx, and this is going to be y dx squared by dx. If you differentiate this part over here, if you differentiate this in terms of x, it's going to be x dy squared by dx plus y squared dx by dx. And now you already have here a term with dy by dx. This is just going to be 2xy. This is going to be the other term with dy by dx. Here you'll have to apply again the chain rule, and it will give you the term with dy by dx. And this is just y squared. Differentiate this. This is 2i. So you have the term 2xy dy by dx. Combine these two. Send the other two to the other side. Factorize dy by dx. Send this to the other side. And here you have the expression. Equal it to 0. The numerator needs to be 0. It's already factorized. So either y equals 0 or that stuff equals 0, which gives a y of minus 2x. So when y equals 0, substitute it on the original equation, that over there, and you'll have an a of 0. When y equals to x, substitute it on the original equation, and you have an x that equals to a. So when x equals a, the y equals 2a, and that is the answer that you want. Why is that? Because on the question itself, it said that a is a non-zero constant. So you automatically exclude this option, and this is the one that you will get over here. So the coordinate of the point is a minus 2a.